Welcome to Knowledge of Physics. In this video I will show you differentiating log of sine inverse x from first principle. This is one of the difficult function to find derivative from first principle, so please stay tuned till the end of this video. To find the derivative of given function, let the function be denoted by y is equal to log of sine inverse x. Let this be equation 1. Then after taking antilog on equation 1 on both sides of equation 1, we get exponential y is equal to log sine inverse x. Actually log is converted into exponential. Let this be equation 2. To find out the derivative of a given function, we have to find out derivative of sine inverse x first. After using the rule of derivative, you can see at the last we can have dy by dx is equal to 1 by exponential y d sine inverse x divided by dx. So derivative of a given function log sine inverse x is equal to 1 by ey exponential y times d sine inverse x by dx. We have to find the derivative of this factor. So for that, put to find the derivative of sine inverse x with respect to x, we have to put t is equal to sine inverse x in equation 2, so that we get sine of t is equal to x, or you can also write x is equal to sine t. Here you can consider x is function of t. Let this be equation 3. Now suppose x and del t be small increments in the value of x and y, in the value of x and t. Here you can see x is function of t, so change in value of t causes change in value of x. Then equation 3 in terms of del x and del t can be written as x plus del x is equal to sine of t plus del t. Let this be equation 4. Subtract equation 3 from equation 4. We get x plus del x minus x is equal to sine of t plus del t minus sine t. X cancel out here, so we are left with del x is equal to sine t plus del t minus sine t. Here we have to divide by del t. Okay, we are going to find the derivative value of d sine inverse x by dx here first. Okay, so that we can insert it simply in next step. Okay, after dividing third last equation by del t, we have del x by del t is equal to sine of t plus del t minus sine t whole divided by del t. Now taking limit on both sides as limit del t tends to 0. This means del t has a very small value, that is very close to 0. Del t has the value very close to 0. Then we get limit del t tends to 0, del x divided by del t is equal to limit del t tends to 0 sine of t plus del t minus sine t whole divided by del t. Okay, this is actually the application of first principle of derivative. To find the derivative by using the concept of limit is actually the first principle of derivative. Here you can write this is the use of first principle of derivative. Okay, now we can write limit del t tends to 0 del x by del t as derivative of x with respect to t, that is dx by dt is equal to limit del t tends to 0 del x divided by del t is equal to limit del t tends to 0 on numerator there is sine of t plus del t minus sine t all divided by del t. Now you can write dx by dt is equal to limit del t tends to 0, and sine t plus del t minus sine t is in the form of sine c minus sine d, and you can use the relation for it as sine c minus sine d is equal to 2 times sine c of sine of c minus d divided by 2 times cos of c plus d divided by 2. Using this relation you get 2 times sine of t plus del t minus t whole divided by 2 times cos of t plus del t plus t divided by 2 whole divided by del t is there. On next step you have dx by dt is equal to limit del t tends to 0, 2 times sine del t divided by 2 times cos of 2t plus del t divided by 2 whole divided by 2 is there. Del t is there. Okay, you can see there cos of 2t plus del t divided by 2, you can take it out from the limit because cos of 2t plus del t divided by 2 does not give you indeterminate form after using del t equals 0. So cos of 2t plus del t divided by 2 is taken out from limit by using del t is equal to 0. So we are left with now dy by dx by dt is equal to there is a cos of 2t plus 0 divided by 2, and that becomes cos of 2t by 2, and limit del t divided by 2 tends to 0, sine of del t by 2 divided by del t by 2. It is because as del t tends to 0, del t divided by 2 also tends to 0. So dx by dt is equal to cos of t times, this term is in the form of theta, limit theta tends to 0, sin theta by theta, and its value is 1. So you can use dx by dt is equal to cos t multiplied by 1, and dt by dx is equal to 1 by cos t, and t is, we have supposed t is sine inverse x, and cos t is root under 1 minus sine square t, and sine t is x, so you get 1 by root under 1 minus x square. So after substituting the value of t, that is sine inverse t, you get d sine inverse x by dx is equal to 1 by root under 1 minus x square. Let this be equation 5. Now we will use this equation 5 to find out the derivative of given function. How we use this, I will show you. Now from equation 2, we have ey is equal to exponential y is equal to sine inverse x, and we use t in place of sine inverse x. Okay, or you don't have to use t there because we have already find the value of, we have already determined the value of d sine inverse x by dx. So in equation 6, let's consider dy, del y and del t are small increments in y and t. Here you can see Equation 6 in terms of del y and del t can be written as exponential y plus del t is equal to t plus del t. And after subtracting equation 6 from 7, we have exponential y plus del y minus exponential y is equal to t plus del t minus t, and t cancels out, y cancels out, t cancels out, so we are left with exponential y times exponential del y minus 1 is equal to del t. Now divide both sides by del y. Then we get exponential y times exponential del y minus 1 whole divided by del y is equal to del t by del y. Now here also you have to take limit as del y tends to 0 on both sides. Then we get limit del y tends to 0 exponential y times exponential del y minus 1 whole divided by del y is equal to limit del y tends to 0 del t divided by del y. And on left hand side you can take out exponential y from the limit, because exponential y is independent of del y. So you get exponential y times limit del y tends to 0 exponential del y minus 1 whole divided by del y is equal to and the limit del y tends to 0 del t by del y means dt by dy. After using the standard relation of exponential del y, we get exponential y into multiplied by 1 is equal to dy by dt. And on the right hand side you have to write in terms of dx, so you get dt by dx multiplied by dx by dy. Okay, and the derivative is dy by dx, because we have supposed y is equal to log of given function log of sin inverse x, so we have to write dy by dx, and dy by dx becomes 1 by exponential y times dt by dx. Now we have to insert the value of y, that is given function log of sin inverse x, and we have also calculated dt by dx. This means d of sin inverse x by dx. After using all these values, we get dy by dx is equal to let me remind you, y is equal to log of sin inverse x and t is equal to sin inverse x. So after using y is equal to log of sin inverse x and t is equal to sin inverse x, so we get dy by dx is equal to 1 divided by exponential log of sin inverse x times d sin inverse x divided by dx. And we have also calculated the value of d of sin inverse x by dx, and the property of log and exponential, so exponential log x means x. Okay, so we can use this property on the factor, right hand side factor of right hand side. That means exponential log sin inverse x becomes log of sin x. Actually, okay, after using this value, you get 1 by root under 1 minus x square. equation 5 is used here. Now dy by dx, y means you can write log of sine inverse x is equal to d of log of sine inverse x by dx is equal to 1 by sine inverse x log of sine inverse x times 1 minus x square. Actually there is a mistake, okay, not all mistake, but one thing you have to correct is, you have to make correction is, there is we have used the here log exponential log x is equal to x, and we wrote there log x as well, so please erase that log. Okay, so you are left with d by dx log sine inverse x is equal to 1 divided by sine inverse x times root under 1 minus x square. This is the derivative of given function log of sine inverse x with respect to x from first principle. I hope you have learned something new, and this function is one of the difficult functions to find out the derivative from first principle. You can write, you can find out derivative easily, okay, by using the rule of derivative, but finding derivative from first principle is difficult. Now try yourself, find the derivative of log of cos inverse x from the first principle. Okay, log of cos inverse x from first principle of, or you can it can also be asked by this way: proof d by dx log of cos inverse x is equal to minus 1 divided by cos inverse x times root under 1 minus x square from first principle. You have to find, or you have to prove this one from first principle of derivative. I hope you have understood the question here. Please comment, drop the comment on comment section if you have found the correct value after finding the derivative of log of cos inverse x. Answer is also given. To find the derivative of function I have given you for the practice, I will show you few hints to find the derivative. Here given function is log of cos inverse x, it is denoted by y, and after taking log you get exponential y is equal to cos inverse x. Then derivative of y with respect to x after using the rules of derivative is dy by dx is equal to 1 by exponential y times cos d cos inverse x by dx. You have to find out first the value of factor d cos inverse x by dx, and then you can further proceed as I have shown you to find the derivative of log of sine inverse x. Please practice it and comment on comment section. Thank you so much for watching.